I'm Anil Kumar, and as you know, we will be talking about calculus, which is all about slope of tangents, right? Now, in this particular video, we'll take up few functions which are very common, and we are going to deal with them in almost every chapter. So I'll take up these functions and we'll figure out what kind of slope can they have, right? So possible values of slope we'll explore for all different kinds of functions which we expect to learn in this particular course of calculus. So let's begin with constant functions, right? So what I will do here is I'll draw a couple of graphs. So let me just make these coordinate planes so that it becomes easy for us to just sketch, right, and get the results, right? So we'll do a couple of them. I don't know how many, but let me make 8 of them here. That should be interesting, okay? So after this video, you should let me know how useful did you find this particular video. Now I'll use a light green color to sketch the function itself. So first graph is about a constant function. So let me write down the name of the functions. We can then sketch this. So we have, let us say, constant function c of x is equals to number 5, right? So the sketch will be a horizontal line, correct? So that is the constant function. Now we could have now another function, a line, which is y equals to, let us say, let me take very simple, y equals to x. So in that case, we'll have a line which is kind of like this, right? Slope is 1 for this particular line, and to continue with this series, we could have y equals to x squared and y equals to x cubed, right? So x squared will be a graph which is kind of like this, and x cubed will be kind of like this. So these are standard graphs which we are going to use. And then let's take absolute x, right? So we'll say a of x is equals to absolute value of x, which you know is kind of like this. Now what you can do is you can also draw some of your own functions and then see. We could take square root, but I'll take cube root rather. So let me say radical function, we will take cube root of x instead of square root, since you know cube root is kind of you could say square root is kind of like this, right? But the cube root is kind of like this. It is has all real numbers as its domain, so that should be very interesting to watch. And then we can have a radical function, which we are, most of the difficult questions will have this kind of function, x to the power of 2 over 3. Now this function is kind of like this, right? So it has a cusp at this point, and that makes it very interesting. So that is one of the functions, and then we could have any polynomial there. We'll think about it. We could also take sine function, right? So we could take a sine function there. Okay, no harm, right? So we'll take sine function. So we'll just make one wave. Okay, so let that be the sine function. Now we will see how to sketch tangent at each and every point and find slope of the tangent and then sketch for the whole function. Now let's begin with the very first one, which is a constant. So if I draw a tangent here, is kind of a horizontal line, right? So it is the slope of that is going to be 0. Since the slope is going to be 0, it should be represented here, correct? So at any point, slope for a constant is 0. Remember that. So it has to be kind of like this. So that is the slope, right? So if my functions are represented by, let us say, if this is f of x, then the slope, I'm using a terminology which you are going to use soon, f dash x. So that is the slope. This represents slope in each graph. Okay. Now in the second case, y equals to x, if I take any point here, we know y equals to x, slope is 1. So in this case, again, we'll have a horizontal line, slope is constant, but it is 1 everywhere, right? So there is a difference when you are working with a constant function. The slope is 0. It is constant, right? But here it is constant, but it's not 0. It's non-negative. I mean non-zero. It could be negative. If the line is dropping downwards, it could be negative. Now here what we notice is that if we take a value here, then the slope is 0. However, if we take a point on the left side, then the tangent will be negative. Now if we see this tangent, if I am starting from somewhere here, it is very large negative, less negative, 0, slightly more positive, positive, and very high positive. So it is constantly increasing from a negatively large value to 0 to positive large value. So what you notice here is that this is a straight line, y equals to kind of, it will be 2x, but it is kind of a straight line. So I'm not writing the value at present, but I'm just sketching, right? So that is the kind of function which you see. Many times in the test you may be asked, increasing and decreasing interval of the tangent to the function. You can see these functions don't increase or decrease, but this is increasing all throughout, correct? Cubic function is kind of interesting. Now here you find it is always, do you see it's always positive? It's positive. It becomes 0 here. However, the tangent crosses the line, it's the curve itself, and it again becomes positive, right? So it kind of, it is always positive. So the slope, if you sketch, it will be kind of a parabola. So I'm just sketching a parabola here. That represents slope of a cubic function. In case of an absolute function, this point is a corner. You cannot really draw a tangent at this point. So it could be many different points. So here the slope is not defined. So slope is not defined at the origin in this particular case. However, it is 1, positive 1 on this half. So we could say positive 1 in this half and negative 1 in this half, because dropping down, correct? So this is kind of negative 1 and positive 1. So that is how this slope is. Now this is another very interesting, the radical part. Now here what you notice is that the slope here is undefined. So it's kind of a vertical asymptote, right? So it's kind of a vertical asymptote. Now this is kind of a going upwards, and when that is the case of the curve, then, and this portion is downwards, it indicates that it is positive. If I draw a tangent here, it is positive, positive. But the positive part is increasing, you see, and it becomes infinitely large at this particular part. So if you have to sketch it, how will it look like, right? How is it going to look like? So that is kind of critical to understand. So it is kind of like this. So that is how it is. And on this side also, what you notice is that this is very large positive. Slope is positive. So it is always positive in all its domain. However, it is infinitely large at origin. So it looks like kind of like this, because here it's kind of tapering down. So it's almost going towards the 0. So here we have a discontinuity on the slope of the tangent on the curve, and it should look like as I have shown. Now when it comes to the radical part like this, now in this case that is a cusp. Now cusp also, this is called a cusp, and here also we have a discontinuity here. But at this point it is almost vertical, so we'll just draw a vertical asymptote. It's extremely high at this point. However, what you notice is that as you move towards away from here, then the slope decreases. Now on the right half, if I draw a tangent, it is going to be positive. So on the right half it is positive and going from a high to a low value, correct? So positive going from high to a low value will be kind of like this, just as you see here. But on this half, it is negative, correct? So it is negative going from negative, you understand, from negative the slope is increasing more and more negative, correct? It's becoming more and more negative, and therefore on this side it is kind of like this. So for x to the power of 2 over 3, that radical root, it is like this. For a sine function, well, I should actually continue this function because there is no break here. Sinusoidal waves are like this. So you can notice here that it becomes 0 at this point, and it is kind of 1 at that point. So when you sketch this, what you get is this point corresponds to a 0, right? And so it becomes like a, and here again it is 0. And at this point, I mean, it goes. So it is more like a cosine graph. Do you see that? 0 here, So let me just sketch like a cosine graph here. So sine tangent, if you draw, you get a cosine function, right? So what, let me write sine function here. It changes to cosine as far as the tangent goes. So that's a good way of remembering it. One very important graph which I forgot here is a reciprocal function. So let me add it somewhere. Okay, so I'm just adding it in here. I hope you don't mind it. So that is, I don't want to really miss that one. So reciprocal function 1 over x is kind of like this, right? Let this be an exercise for you. Okay, so we have many graphs like this. This is 1 over x. Okay, let me write 1 over x here in another ink. So we have r of x equals to 1 over x. Now you will notice that this graph, if I draw a slope at any point or tangent at any point, then in this half what we notice is that it is negative, right? Here also it is always negative. So you find that the slope is always negative for this particular function, and it is always, if you see, the graph is always decreasing. Do you see that? So it is becoming more and more negative, right? So as an exercise, I'd like you to sketch the graph of this one. Some of you can now pause the video, answer the question, and then look into my suggestion. But anyway, here is kind of the graph for this. It is kind of reverse of this. So what you get is kind of reverse of this. So that is approximately the graph for the slope of tangent for the given function, right? So these are few functions which we will be covering in calculus, and it's a good time to review them and understand how tangent at every point will be. Now as an exercise, what you can do is you can take up a reciprocal function and prove that the slope of the tangent is never positive, right? You can take up cube root function and prove that the slope of the tangent is never negative, right? So that is how you can take a few questions from here, and well, that is difficult for you to prove, but anyway, these you can definitely do. So just prove that the slope of a reciprocal function is always negative, and slope of cube root function is always positive, right? So I hope that helps. Thank you and all the best.